For billions of years, the cosmos has kept its most profound secret locked away in the dark. We have stared into the void, counting trillions of distant stars, wondering if anyone else is staring back. Now, humanity is preparing to launch its most expensive, daring gamble to find out. This is not another telescope designed to look at abstract gas clouds or distant explosions. This is a machine built for a single, terrifying purpose: to take a direct photograph of another Earth.
NASA calls it the Habitable Worlds Observatory, a monumental, multi-billion-dollar endeavor slated to redefine our place in the universe. For decades, our space telescopes have relied on shadows and math to guess what lies beyond. We watched stars dim as planets passed in front of them, inferring their existence through calculation. But we have never actually seen them. The light of the host star is a blinding searchlight, completely drowning out the fragile glare of a planet. To capture an alien world, you must first do the impossible. You must blot out the sun.
Imagine trying to photograph a tiny firefly floating inches away from a coastal lighthouse, from a distance of thousands of miles away. That is the exact mathematical challenge NASA engineers are facing. The Habitable Worlds Observatory will utilize a terrifyingly complex piece of engineering known as a coronagraph, an internal masking system capable of filtering out starlight with a precision of 1 part in 10 billion.
When this machine deploys its massive mirror in deep space, it will lock on to a neighboring star system. The coronagraph will slide into place, creating a perfect artificial eclipse. The blinding glare of the alien sun will vanish, and out of the ink-black darkness, a faint, solitary pinpoint of light will emerge. A tiny, pale pixel floating in a sea of nothingness. For the first time in human history, we will be looking directly at the surface of an alien planet.
But a photograph is only the beginning of the nightmare, or the miracle. The true magic happens when that tiny dot of light is split apart. The telescope will break the planet's reflected light into a barcode of colors using advanced spectroscopy. This light will tell us exactly what the atmosphere is made of. If a world is dead, its air will be stagnant, filled with toxic carbon dioxide. But if that planet is alive, the light will betray its secrets. It will reveal the presence of gases that shouldn't be there.
We will be hunting for biosignatures, the unmistakable chemical fingerprints of life. The telescope will scan for free oxygen and methane existing together. On a dead rock, these chemicals destroy one another, vanishing into inert compounds. Only a global, active biosphere can constantly pump them back into the sky. If the Habitable Worlds Observatory detects this chemical imbalance, it will mean only one thing. We have found a living, breathing, alien ecosystem.
The scale of this mission requires engineering that pushes the absolute boundaries of human capability. The mirror itself must remain perfectly still, stabilized down to the picometer level, a distance smaller than the width of a single atom. Any tiny vibration, any slight thermal expansion from the heat of the sun would distort the alignment and ruin the image. The telescope will operate in the absolute freezing isolation of the second Lagrange point, 1,000,000 miles away from Earth. There, shielded from the heat of our own planet, it will quietly point its massive eye at 25 carefully selected target stars. 25 systems that hold the highest probability of harboring an oasis. We are looking for oceans. We are looking for continents. We are looking for the faint green tint of alien vegetation, or the reflective glint of liquid water. This multi-billion-dollar eye is our first real bridge across the interstellar void. If the mission succeeds, the psychological impact on humanity will be permanent. The universe will suddenly feel much smaller and infinitely more crowded. We will look up at a specific point in the night sky, point to a star, and know with absolute certainty that something is living there. The lonely cosmic dawn of humanity will finally come to an end. We will no longer be an isolated anomaly, floating on a lonely blue marble. Yet, there is a darker alternative that scientists rarely speak aloud. What happens if the telescope works flawlessly, blots out the stars, analyzes the 25 worlds, and finds absolutely nothing? What if every single spectrum comes back completely barren, cold, and dead? A universe of endless silence. If you want to visualize what these alien environments might actually look like through the lens of modern astrophysics, you can check out this deep dive into how the James Webb Space Telescope studies exoplanet atmospheres. This video breaks down the real-world science behind parsing cosmic light for atmospheric signatures, which forms the direct foundation for NASA's upcoming multi-billion-dollar mission.